Alright, we're going to be talking about rational functions, especially graphing rational functions. Here is the definition of a rational function. Alright guys, when we graph rational functions, you need to find the asymptotes. So there's vertical, horizontal, and oblique asymptotes. So first, to find the vertical asymptote, you just set the denominator equal to 0 and then solve for x, and whatever you get is x equals, and that's your vertical asymptote. For a horizontal asymptote, you got to remember these three kind of rules. The first rule is if the numerator is less than the denominator. So if the denominator has a bigger degree or a bigger exponent, it's y equals 0. If the numerator and denominator are equal, we look at the leading coefficient. So we look at the number in front of those variables with the highest degree. And that's what we take as that fraction, the two coefficients over each other. And then see if the numerator is higher than the denominator, there's no horizontal asymptote. If there's no horizontal asymptote, there's going to be an oblique asymptote. That's when the degree is one higher on the top than the bottom. What we do is we use long division, and then we just write our as y equals, then whatever is left, we don't worry about any remainder. So for this first one, our vertical asymptote is setting the bottom equal to 0. So we're going to have 2x squared plus 5x minus 3 equals 0. Okay, so what thing's factored in -6 but adds up to +5? Well, that's going to be a +6 and a -1. So we have 2x and x. Okay, so we know that 2 goes into 6 3 times, so it's going to be +3. And then the -1 goes here. So that means that our vertical asymptotes are going to be x equals 1/2 and x equals -3. -3. Okay, that's our vertical asymptotes. For our horizontal asymptotes, okay, we're going to check to see our degrees are our exponents. So this exponent is technically a 1. This highest exponent is 2. So since the bottom is bigger, our horizontal asymptote is y equals 0, which we talked about in the last 2 slides ago. Okay, now we're going to find our asymptote or our intercepts. So for our x-intercept, okay, we're going to set y equal to 0, and we're going to just solve. So if we do that, we have 0 equals x plus 1 over this 2x squared plus 5x minus 3. Okay, now if we think about a fraction, the only way that we can actually get a fraction to equal 0 is the top has to equal 0. So technically, we can just kind of ignore this bottom and just set the top equal to 0. So we have x plus 1 equals 0, so x equals -1. So our x-intercept is -1, 0. Okay. I'm going to kind of... Now to find the y-intercept, what we do is we set x equal to 0. So for this one, we have 0 plus 1 over, I'm going to change color so that we can see it, 2 times 0 squared plus 5 times 0 minus 3. So if we simplify that, it's just going to be 1 over -3. So our y-intercept is 0, -1/3. Okay. It doesn't want us to graph it, it just says find them, so we're done. Let's go to the next one. Okay, so our vertical asymptote, remember we set the bottom equal to 0, the denominator equal to 0, so x minus 3 equals 0, so x equals 3. Okay, now our next one, our horizontal asymptote, we look at our degrees. Well, I have x to the first and x to the first, so we just look at the coefficient, so it's 2 over 1, which is just 2, so this is going to be y equals 2. So we just look at the numbers in front of our highest degrees. Okay, so for our intercepts, to find our x-intercept, we're just going to plug 0 in for y. Well, that ends up just making, we set the top equal to 0, so we have 2x plus 1 equals 0. So that's going to give me -1/2. That's our x-intercept, so -1/2, 0. Okay, our y-intercept, we're going to go ahead and we set the, for the y-intercept, we'll plug 0 in, so we're going to have 2 times 0 plus 1 over 0 minus 3. So we get negative 1/3. So that's our y-intercept. So let's go ahead and actually put our asymptotes on there. So my vertical asymptote is going to be x equals 3. And my horizontal asymptote is y equals 2. That's a pretty bad line. All right, and then now we can go ahead and plot our x and y intercepts. So negative 1/2, 0. And then negative 1/3, or 0, negative 1/3, so right there. We only really need the intercepts, and the asymptotes is all I want, and then you can sketch based off of what we know that these graphs are going to look like. If you want to plug in different x values, like if you wanted to plug in what 1 would be or what 2 would be, for plug those in for x and see where the y's would be, you can do that if that helps you out. Or you can just kind of know what we know about intercept or asymptotes, is it's going to get really, really close to this vertical asymptote, and our end's going to get really, really close to this horizontal asymptote. Okay? And then it's going to look reflected over on the other side for this one. And now to talk about domain and range, I'm going to just scroll up a little bit. Well, it goes to the left forever, so domain is going to be negative infinity. And then it's going to stop at this asymptote at 3. So it's going to stop at 3. So it's going to be parenthesis. Now it's going to start up on the other side of 3, go on to positive infinity. Okay. Our range, it starts at negative infinity, and then it goes all the way up to that 2 asymptote, that horizontal asymptote. Then it starts back up at 2, and it goes up forever. Okay. Now if we look at this one, find our vertical asymptote, set the bottom equal to 0, so this is just going to be x equals 2. Okay. And you can just come over here and make that, if it's helpful for you to make the asymptote right away, you can. Okay. Now if I look, the top has a degree of 2, the bottom has a degree of 1, so it does not have a horizontal asymptote, which means it's going to have an oblique asymptote since the top is bigger by 1. So I need to use long division, so I'm going to x minus 2, and long divide that by x squared plus 0x plus 1. Okay, so x times what gives me x squared? Well, that's just x. So I have x squared minus 2x. Okay, we subtract. So that gives me 2x and then plus 1. All right, we're going to go ahead and say what x times what gives me 2x. Well, that's just 2. So I have 2x minus 4. Okay. Now I'm going to go ahead and subtract. So we get a remainder of 5, but that really doesn't matter. I'm just going to use this. We don't care about the remainder when we do this, so we have y equals x plus 2. Okay, so that's our oblique asymptote. I'm going to go ahead and clean up the work so I can use the graph. Okay, so now I'm going to go ahead and graph that. So starting at 2 with a slope of 1, I can go ahead and graph that oblique asymptote. All right, now our intercepts. I'm going to go ahead and, for our first one, I'm going to do my x-intercept, so I'm going to plug in 0 for y, so we have x squared plus 1 equals 0. Well, right away I have x squared equals negative 1. Well, I kind of notice if I square root both sides, it's going to give me an imaginary number, so that means that there just is no x-intercepts. Okay. For our y-intercept, we just plug in 0 for the x's, so we have 0 plus 1 over, or 0 squared plus 1, and then 0 minus 2. So that's going to give us negative 1/2. So we're going to have 0, negative 1/2 is our y-intercept. Okay. Let's go ahead and plot that. So 0, negative 1/2 right there. Okay. We know it's not going to have an x-intercept, so it's just going to look something like this. Okay. And it's going to look the same over at the other side. All right, our domain. Well, it doesn't want our domain range for this one, so we can just go ahead and move on to the next one.